Okay. So we will create a table. X values will be 1, 2, 3, 4, 5, 6, 7, 8. Right?
Yes.
Okay. Can you tell me y values? You can use a calculator and tell me y values.
The y values will be 3,
3.
1.5,
Good.
0.75,
7, 5. Yes.
0.6,
Hmm.
0.5.
Okay. That's enough, right?
And it's as x is increasing, y is decreasing.
Yes. So what is the conclusion?
It is an inverse.
Inverse variation. Good. Inverse variation. Okay. Then what about this relation?
Neither.
Neither. So isn't there any easy method for pointing out an inverse variation, direct variation? When there is a product, x and y as a product, it's inverse, right? When x and y,
so I think the best way to do this is to rearrange your solution until it reaches x, y, like equal to something.
It is equal to a constant value, right?
Yeah.
It should be equal to a constant value. Yes.
So I think you should rearrange your solution until it equals to like this.
So this format means inverse variation.
Yes.
Right? When y is equal to a number times x, y is equal to, let's say, m times x, m is a constant value. So this kind of relation are called direct variation, right?
Yes.
Okay, I have few questions. You have to identify the type of the variation, right? I'll give you few questions. Y is equal to 4x. You can write the type of the variation, inverse, direct, or neither. Y over x is equal to 4. Y over 4 is equal to x. X, y is equal to 4. X is equal to 4 over y. Okay, you can try. It's okay to make mistakes. The thing is, you can learn from your mistakes. You can read, I will write. First one?
The first one will be a constant, right?
Y is equal to 4x.
So if y is 2, that means if it's increasing.
And
x is also 2, so that's going to be 8. 2 is equal to 8. That's going to be a constant. It's increasing.
Yes. So your answer will be direct, inverse, or neither. From these 3, what is your answer?
So this one's a direct.
Direct. Very good. Yes, I will write. You can take time. No need to rush. You can, if you need, you can draw a table and find the answer, right? No need to rush. Take time, be calm, and find the answer. What about this one? Y over x is equal to 4. You can rearrange terms, create a table, and find the answer.
So this would be so this one's gonna be an inverse.
Inverse. Yes, very good. This one?
Yeah, this one.
What is the reason for that? Y is equal to 4x. After rearranging the terms, we get y over 4 is equal to x.
Yes.
Right? So this 4 is going to the other side as the numerator. So y is equal to 4x. Same, right? If
yes.
This is direct, this one also direct variation.
Oh, I think I messed up on my graph.
Sorry?
I messed up on my graph.
No, I can support you, right? So what about this second question?
Oh, the second one will be an inverse because it's going to be y over x.
Rearrange the terms. Y over x is equal to 4 means how to rearrange the terms?
So you times 4 on each side, so it's going to be y equal to x4.
Y is equal to 4x.
Yes.
What can you say about this variation?
Also, it's also going to be direct.
Direct. It will be direct variation. Question number 4.
This one will be an inverse.
Very good. Inverse. What is the reason for your answer?
Because it's in the xy. Like
yes, xy product is equal to a constant value, right?
Yes.
This question, you can rearrange the terms. X is equal to 4 over 1.
That will also be an inverse. Because if you just multiply y, it'll just go over here.
Yes, xy is equal to 4. So it's inverse. Good. Okay, we will go to the next question. Question number 6. Okay, read the question number 6, Sino.
The variables x and y vary inversely. And y is equal to -4. And when x is equal to 6. An inverse variation equation that relates to x and y. Find the value of y when x is 3.
Okay. What did you get? Could you please explain?
But y is -4, x is 6. So that means when y is decreasing, x is increasing.
How do you conclude that? We have only one data point.
Because this one's a positive and this one's a negative.
That's not enough information.
So
here we have been given very inversely. They have given the information very inversely. Right? This is the information. Right? By looking at those numbers, we cannot conclude whether it is inverse or direct. Right? At least we need 2 data points. There is only one data point, xy. Xy means 6, -4. There's only one data point. Right?
Yes.
So we cannot conclude by looking at this data point whether it is inverse, whether it is direct or neither. But they have told us that the variable x and y vary inversely. That is the information. So,
okay. So it's
okay. Xy is equal to?
Xy is equal to?
Read the question.
-24.
Very good. -24. So this is the relation of the equation, right?
Yes.
Okay. Then find the value of y when x is equal to 3.
Oh, so you have to just like divide 24 by 3 and you get 8. Oh yeah, 8.
8. You have.
So it'll be negative
yes,
8.
-8. When x is equal to 3, y is equal to -8. Very good. Okay. Then question number 7. Read 7th question,
The second question will be talk about our order pairs: -20, -3, comma -12, -5, comma -10, 10, 6, comma 5, 4. No, 15, 4.
And 14, 1.5.
I can't hear you properly.
Am I audible to you now?
Yes, that's better. Yes.
Okay. Sorry for that technical issue. I will fix that again. Okay. Represent inverse variation. If so, write the inverse variation equation. So we have been given 1, 2, 3, 5 data points. 5 points. Right? By looking at those points, we have to check whether this is an inverse variation or not. What is your conclusion? How to do that? How to conclude that?
We could just multiply all the numbers. So 20 times 3 is negative. So the negatives cancel out. So that would be like.
Okay. Yes. Go ahead. Your answer is correct. Plus 60.
And 12 times 5 will be also 60.
Yes.
10 times 6 will be 60. 15 times 4 will be 60.
Are you sure?
15 times 4.
Yes. 15 times 4 is 60.
And 40 times 1.5 will be. So that'll be 40 plus 20. That'll be 60.
Very good. So what is your conclusion?
So.
Is it inverse or not? Am I audible to you?
Yes. I just typed it. Inverse.
Good. Correct. So if so, write the inverse variation equation. Good.